Hello, my name is Jim Fettinger, and I'm the director of the Small Molecule Crystallography Lab here in chemistry at UC Davis. We have a lab that has 4 instruments that are all located in the basement of the chemistry building. 3 of them are single crystal and 1 is a powder instrument. On average, we collect a little over about 900 samples a year, and we have anywhere between 40 and 55 active students along with myself collecting these data. So this is our Apex 2 X-ray diffractometer. It's equipped with a single source Moly tube, and it has an Apex 2 area detector on it. It's equipped with a Cryo Industries low temperature system that allows us to collect data anywhere from 90 K up to above 300 Kelvin, should we wish to. We collect, on average, about 100 data sets a year on this instrument, and it has been extremely reliable for the many years it's been in operation. So this is our Duo X-ray diffractometer. It has a dual source system. It comes with a molybdenum sealed tube and a copper microsource. The microsource is a first or second generation. It runs at 28 watts. The area detector is an Apex 2 detector, which again collects really fantastic data. The diffractometer has a low temperature system, another Cryo Industries system, which again can go anywhere from a low of 90 Kelvin up to over 300 Kelvin, depending on the type of sample that you're examining. The system has been in use for over a decade, and it collects extremely good data.
What is a duo system?
So in this case, the duo system means that it has 2 different sources. In here we have a molybdenum sealed tube source, and in the front we have a copper microsource. The microsource is 28 watts, where the molybdenum tube runs at around 1500 watts, which is a lot of power, but we only get a little portion of that. So the major reason we try to use molybdenum is because overall you can get higher resolution on your data sets. If we have a bad crystal or something that does not diffract very well, and we find that we can't collect very good data with molybdenum, we can switch to copper, and then the copper data set is usually much more intense, since the copper source is about 30 times more intense than the Moly. And then we can collect an entire data set, and in many cases it's publishable. So the Moly source wouldn't be publishable, what the copper source would be. So this is our single crystal Bruker D8 Venture dual source system that has both a copper and a molybdenum microsource. It's also equipped with a photon 2 detector, and it has a Oxford Cryosystems low temperature system, which we run anywhere from 100 K up to anywhere around 300 Kelvin. The system collects about 200 data sets a year, and it's used almost every day. So this is our Bruker D8 Advanced Powder X-ray diffractometer. It has a copper source, a sealed tube, and it has a lynx eye detector, and it also comes with a 9-position sample changer. So you can collect up to 9 samples at any one time. It runs at room temperature though, so we do not have variable temperature capability. So now that you've seen the 4 instruments and how each of them have been described, you should know that you're all welcome to use the lab at any time. We have about 15 research groups and 45 to 55 active students at any one time. So all you have to do is feel free to contact me, James Fettinger, here in the chemistry department, and we will work through a procedure for you to learn how to use the instruments and become an authorized user of the lab.